13.1 is called GCF and factoring by grouping. Now, what GCF stands for is something that we call the greatest common factor. Okay, so what the greatest common factor means is what is the biggest number or biggest factor that we can factor out of our polynomial. So I want you to notice here we have 5x plus 35. That polynomial has two terms. The first term is a 5x, second term is a 35. So I'm trying to figure out what's the biggest number that goes both into 5x and into 35. Well, that number would be 5. Now if I factor out the 5, factoring is sort of like the opposite of distributing. I have to figure out what would I have to put on the inside here so that when I distributed my 5 to both terms, I would end up with 5x plus 35. Well, I'd have to put an x here because 5 times x would give me 5x. And I'd have to put a 7 here because 5 times 7 gives me 35. So in the factored form, my answer would be 5 times x plus 7. Again, just to sort of illustrate what I mean by that, if I multiply that out, that gives me 5x plus 35. So I'm really looking at this as my answer because when I multiply that 5, that's what I get. Okay, so let's do the same thing with this second problem here. I'm trying to figure out what's the biggest number that's common between 24 and 6. So the biggest number common to both 24 and 6 would be 6. Okay. So now 6 goes into 24 4 times with an x because there's an x there. Minus, because I have a minus right here, 6 goes into 6 once. Okay. All right, let's take a look at the next part. So here I have x to the fourth plus 5x to the third. So I want to figure out what's the most number of x's I can take away from x to the fourth and 5x to the third. Well, the most number of x's I can take is 3 of them. So if I had an x to the fourth and I took away 3 of them, I'm left with an x still left over. And I have a 5x to the third here. If I took away that x to the third, the only thing I'm left with is the number 5. Again, if I want to check my answer, right, I'm going to go ahead and distribute. So x to the third times x is x to the fourth. X to the third times 5 is 5x to the third, right? Okay, great. Let's try the same thing with the next problem. 3x to the fifth plus 27x squared. Okay, so I know I can take a 3 out of both of them because 3 goes into 3 once and 3 goes into 27 9 times. And between x to the fifth and x squared, I know I can take out an x squared. So I already took the 3 out. If I had an x to the fifth and we took out 2 of them, we should still be left with an x to the third. And 3 goes into 27 9 times. We had an x squared, but we took it out. And so we're done. Again, if you want to make sure that you're doing this right, you can always say, let me check my answer, right? And if you multiply that back out, there's your 3x to the fifth. And if you multiply that out, there's the 27x squared, right? Okay, great. All right, so we're going to do the same thing here in this next problem. I'm going to, let me get my pen again. Okay, I'm looking at those two terms. The one thing I know they both have in common is the letter y. If I factor out the letter y from here, I still have the letter x. If I factor out the letter y from there, I still have the number 3. So again, factoring is just the opposite of the distributive property. We're sort of going backwards. It's like here was the answer, and that was the problem that we had, okay? All right, I'm going to take a look at this next problem. I notice it's real similar to the one we did before. If you notice from here and from here, we have the same piece. We have a y plus 6. So if I factor out the y plus 6 from this piece, well, we still have that letter x plus, because there's a plus here. If I factor out the y plus 6 from that piece, I still have the number 3, right? Okay, so in this next part, again, all I'm doing is factoring out the greatest common factor. What is common to all three parts? Well, the number 3. So I take the 3 out from there, there's an x, minus, because there's a minus here. 3 goes into 12 4 times with a y, plus 3 goes into 3 1 time. Okay. I'm going to do the same exact thing in this next part here. So the first thing I want to figure out, what number is common to both 6, 12, and 9? Well, the number 3 is, but I also want you to notice that those 3 terms also all have the letter x. So we're going to factor out an x. So 3 goes into 6 2 times. We had an x to the third. We took one of them out. Now we're left with an x squared. 3 goes into 12 4 times. We had an x squared, but we took one of them out. So there's only one x left over. And 3 goes into 9 3 times. We had an x, but we took it out. So there's no more x's there. Great. Okay, let me go ahead and scroll down some more. So same thing here with these next two problems. There's my common factor, so I have an x squared plus 2. Okay. If I factor out that from the first piece, I'm still left with the letter y. There's a plus in the middle. If I factor it out from the second piece, I'm still left with the number 3. And we're done. Okay. So in this next problem, I want you to notice something here. I see my two pieces. I see what they have in common. I see that I have my little r here, but I don't see anything here. I can always think about that, though, as the number there. You know what? Let me do this. And I can think about the number here, bring the number 1. Okay? It's an imaginary one, you know, doesn't change anything. But now, if I look at my common factor, I say, okay, well, look, we have a z to the third. Sorry about that. Minus 6. And what am I left with? An r minus 1. Okay, good. So now the next part is something we call factoring by grouping. Factoring by grouping is just like we did those problems right there. And what we're going to do in factoring by grouping is I'm going to look at these first two pieces here. And I'm going to look at these two pieces over here. Okay. And I'm going to look at them separately. So my first question is going to be, out of these two pieces, what can I factor out of both of them? Well, you know what? We can factor out an x squared. And if I factor out an x squared, what am I still left with? I'm left with an x plus 2. Now, what can I factor out of those two pieces? Well, the number 5 is common to both of them. And what are we left with? If we factor out the number 5, we still have an x plus 2. So again, when I notice, well, hey, look, my common factor here is an x plus 2, what am I still left with? An x squared plus 5. Okay? And that's what we mean by factoring by grouping. Okay, so let's take a look at the next problem here. I'm going to do the same thing. I'm going to box these two. I'm going to circle those two. So the first thing I notice is that in that box, I can factor out the number 5, and I'm left with an x plus 3. And in this circle, there's a plus there, so I want to forget my plus. I can factor out the letter y, and I still have an x plus 3. And so here's my common factor, x plus 3, and 5 plus y. All right, continuing with our factoring by grouping. So, I'm sorry, let me get my pen again. So I'm going to go ahead and box the first two, circle the second two, okay? So I want to look, what can I factor out of both those pieces? So what number is common to both 16, x to the third, and 12x? So some people might say, well, 2 is common to both 16 and 12. Remember, we're looking for the greatest common factor. So 4x is common to both of them. So 4 goes into 16 4 times. I had an x to the third. I took one of them out. I'm left with an x squared. 4 goes into 12 3 times. Okay. Now I'm going to look at these two terms over here and say First thing I notice is that this first piece here is negative. So whatever number I'm going to take out, I'm going to take a negative number out. So between 28 and 21, the one number that's common to both of them is the number 7. So 7 goes into 28, 4x squared. Negative 7 goes into negative 21, a positive 3 times. Again, if you notice, there's my common factor. So right here I'm going to write out 4x squared plus 3. And my second piece will be a 4x minus 7. And there's my answer. Okay. All right, let's try the next one. So again, my process is always going to be the same. I'm going to box these first two. I'm going to circle the second. So 8x squared plus 7xy. I don't have any numbers common to 8 and 7, but I notice that both terms have the letter x. So I'm just going to factor out the letter x. Now I'm left with an 8x plus 7y. Again, since there's nothing common to both of those, I can always rewrite it, but with the number 1 in front. And the reason why I want to write it with the number 1 in front is that now I can see my common factor, 8x plus 7y, and my other factor that I'll be left with would be x plus 1. Okay. So again, what I really want you all to sort of understand here is that the process of factoring by grouping is always going to be the same. I'm going to do the same thing every time. I'm going to take my time with these problems. I'm not going to rush. And one thing I always tell my students, I'd rather be the last person to do the problem and finish and get it right than be the first person to do it wrong and then I got to do it all over again. Okay, so again, if you notice, box the first two, circle the second two. Out of those first two terms, I can factor out an x squared. If I factor out an x squared, I'm still left with a number 2 here. I had an x to the third. I took away 2 of them. I'm left with 1x. Okay. X squared goes into x squared 1 time. Okay. Out of 8x and 4, the biggest number I can factor out of both of them is the number 4. 4 goes into 8 2 times. 4 goes into 4 1 time. Again, here's my common factor, 2x plus 1, and my second factor, x squared plus 4. Great. All right. And so the last problem here in factoring by grouping, again, let's box the first two, and let's circle the second two. You know what, let's go with a red on this one. Okay, so out of 4x squared and 8xy, I can take out the number 4. They both have a letter x. So 4 goes into 4 once, but there's still an x left over. 4 goes into 8 with a minus 2 and a y. Again, the first thing I notice here, that piece is negative, so I'm going to write a negative here. Between 3 and 3x and 6y, I can take out the number 3. So let's see, negative 3 goes into negative 3 1 time with an x. Negative 3 goes into a positive 6 with a negative 2 and a y. That's my common factor, so x minus 2y. And again, this one here is my other factor, 4x minus 3. So go ahead and give section 3.1 a try and see what you guys think.